Thank you. Well, good morning. I'm going to be talking to you about tree pit design. It's a very interesting area, designing tree pits. We're finding that the further we go in looking into this, the more that there is to learn and the more there is to contribute. Just to cover off on a few things, do we have environmental issues in cities? Well, I'd say, do we ever? We have the urban heat island, which is as we all know, it's the temperature differential between our cities and the surrounding urban or rural areas. And a lot of this can be mitigated, as we know, through better design than some of the things that we're seeing here. We've got issues with polluted outflows. So our stormwater is being polluted, and trees can have a measurable part to play in mitigating that. A lot of our infrastructure is ageing. So we've now got situations where the consent authorities are saying to developers, we can't handle your stormwater. You need to deal with that on site. And we've got more and more people living in cities and needing green space. So I'm going to talk about a couple of aspects of how we can seek to address that with trees. Designing for heat mitigation to start with. This is some data out of Texas, but you'll find it's pretty typical from what we find in various regions, but the temperature differential between cities and surrounding areas is severe, and it's being recognised now, and something that really needs to be addressed through correct placement and growth of the tree canopy. And I just noticed this recently. This is a couple of slides just indicating the difference in temperature beneath a tree canopy and where there is no canopy. It's about 20 degrees often in the middle of summer. And so we need to start by finding the hotspots. And as we know, there's a lot of work being done currently, and it can be done at a number of different levels. It can be done by satellite, by aeroplane, and then coming down closer for higher degrees of accuracy using LiDAR. But we need to find where are the hotspots, where are the hottest parts of the project we're working on. So this is a KFC in Darwin, and what we see there is a building. So that's the building here, and this is the car park, and you can see the extreme heat there, and then we've got some tree canopy here, and you look at the roadway as well. It's just extremely hot on the roadway, and this is one from a residential development. Once again, we can see the cool areas where we've got tree canopy, and we can see the heat that there is on some of these roofs and on the roadway. It's pretty severe, but there's a lot of technology that's coming along now that's helping us to identify and zero in on some of these issues. So to start with, let's agree on what's our target shading ratio that we want to achieve. So it may be a car parking lot, it may be a streetscape, but at the street level, what percentage canopy cover do we want? Or what percentage of shading do we want? And by when? So this is the level of accuracy that we are trying to drill down on now, is a percentage by a target date. And as we know, trees have got I've borrowed this from an ASLA session in America, but there's 6 basic ingredients for trees, and we need to address all 6 of them. So we need to have sufficient soil volume for the trees. We need to have room for the trunk flare to develop. We need to have water going in, and we'll cover that off in more detail shortly. and the water that goes in needs to be able to get out. We need room for the canopy growth, and we need quality nursery stock, and I believe that's coming up soon as well. So the soil, the volume of soil that we provide is directly influences the size of the canopy we get. But what we're going to talk about now is reverse engineering that, working back to a soil volume from a target canopy cover. So here's just a simple example of a parking lot, and we might wish to introduce some trees into an area that's got no shade, and we want to achieve a certain percentage canopy cover. So we'll identify the areas that we want to cover, and we'll just start playing with some circles. Leave the tree species aside for the time being. Let's work first in the areas of shading that we want to provide, and then how many will be needed. And then from there, we'll back calculate the soil volume that we need. So one of the interesting formulas that's come up in Australia is started as a rule of thumb that for every 2 square metres of shade that we want to provide, we need to provide 1 cubic metre of loam soil. Now we'll run through the case study regarding this in a few minutes, but it's a simple rule of thumb. It ties in very, very closely to what's known as the Crown projection formula, which is 0.6 of a metre in depth times the area of the mature tree canopy. So it's virtually identical. These are all rules of thumb. There's much more complex formulae out there, as we know, that take into consideration regional evapotranspiration rates, etc. But this is a good rule of thumb. So that's for shading. Now, another aspect is that runs parallel with this, and we strongly endorse it being done in conjunction with, is designing tree pits for water-sensitive urban design. Now, we've been doing this for a long time in a fairly basic sense in terms of passive irrigation, where we'll provide some curb cutouts and let the water off the road into a tree pit. We'll cover that first. What we've actually built is a water balance tool, which, with the assistance of some stormwater engineers and some agricultural scientists, brings in things like crop factors, and we can upload regional specific rainwater data. And we can look at things like cumulative wilting days for the tree pit that we've just designed with that species. So we can play with things like the tree type, is it exotic or a native? So some of these things are fairly simple parameters, but it's amazing once you start playing with some of those details, how it changes the tree's usage of water, the catchment area, for example. So that's really about passive irrigation of the tree. The other really fascinating thing is that we can now, using software available, model pollutant removals. So now what we're seeing is the tree pit actually becomes a functioning part of the stormwater treatment train. And it's brilliant because it's like an overlap of a couple of disciplines. So what we can do is look at what the pollutant removal targets are for the region you're working in, and then we can look at the positions where street trees can go, and then we can check the catchment area, for example, per tree. Now, it's key that we get this right, because what we found is there's a correlation between catchment area and surface area of the tree pit. So what we use with some of these vault systems that we do, I think we've got a few pictures of them here, we leave the soil down a little bit by about 100 millimetres so that the water that comes into the pit can pond across the surface. That's the key with water sensitive urban design, is surface area, of the treatment device. So what we're doing essentially is taking the established science of bioretention and rain gardens, etc., and instead of trying to plant a tree in that, which, as you'd all know, doesn't work, to try and grow a tree in a soil media that's got a very high hydraulic conductivity, we're using loam soils, which has a slower infiltration rate, which means we need more of it, which plays right into our soil volume calculations. So what we're saying is, if we calculate the soil volume calculations for the tree based on arboricultural science, and then we look at the surface area of the tree pit as required for water-sensitive urban design, often they're fairly close. But we need to get it right, and we need to work on local environmental data, i.e. there's a band, an optimal band between catchment area and surface area of the pit. If it's too little, if the catchment area is too small for the tree, well, the tree won't be getting the benefit of the water that it could be. If there's too big a catchment area per tree pit, the tree could be getting too much water, if that makes sense. Really good thing about this is it's giving us a much broader tree palette that we can play with in cities. So if we're just trying to grow trees in bioretention pits, you end up with a very narrow species selection, because not many trees will actually survive in those sort of growing conditions. But by growing trees in loam soil, that gives us back much more choice for tree selections. And very simply, what we're doing with all this is we're reconnecting, if you like, the environmental cycle in cities. Instead of having something that's broken, where we have a tree in paved area and the water's being efficiently directed towards storm drains, pipes, and then ending up in a culvert or a drain or a river system, that does a lot of damage, as we know. We get the peak flows in rain events, and that the water comes off at much greater velocity, does damage with erosion and turbidity, upsets the balance of life in the river system. So what we're about is capturing that water, bring it down through the pavement, which we can via permeable pavements or rain gardens or strip drains or whatever, get that into the loam soil underneath, where the tree's root system can access that moisture, suck it up, pump it out via evapotranspiration, do the cooling and the accelerated growth that we're looking for. And this is just a very short story about the catfish in the bathtub. I won't name the city in the US where it was, but I had to go to a project in the United States. And it was on the banks of a large river, like a seriously decent sized river. And I said to a lady there, I said, it was middle of summer. I said, do people swim here? And she said, oh no sir, it's too polluted. She said, you can't even eat the fish out of here. My husband catches catfish and puts them in the bathtub for a couple of days in fresh water to get the toxins out of them, then he eats them. So that's interesting. And then went downtown for this meeting with the city. And it was a large installation of some of our stuff there. And I relayed this story to some of the people there, and they said, oh yeah, the parks manager said, we can't even water our trees from that river. And I suggested, well, this loam soil you're putting here under the sidewalk, we could be taking water off the road, putting it through this soil, taking some of those harmful pollutants out of it, and fixing it there rather than it gets into the river system. The thing I love about it, it's not rocket science. It's just realising that this stuff can be done, and it's so simple. But with some of the software that we've got nowadays, we can model it and we can measure it. So I'll just go through a few case studies and then we'll take some questions. This is a project where we were, a inner city council in Sydney was doing a trial with a tree which actually is taking runoff off the crown of the road, and the water goes through a permeable paver system, and the trees are doing exceedingly well. This is a continuous vault system that we did with some lophostomins in it, which are also, this is a simple passive irrigation scheme, so the water comes down the road curb, spills into those pits, and then finds its way down into the soil underneath. There's one in particular I'm looking for. Yeah, this one here. So this is a really interesting one. This is an urban forester in Western Australia who he really came up with this theory of 1 cubic metre of soil for 2 square metres of shade. He thought that you should be able to reach it in 15 years. He persuaded his parks manager to fund a trial. So it was a completely self-funded trial in a car park. And these are the numbers that they were providing per tree. So there was 16 cubic metres per tree of soil under the car parking spaces, 9 cubic metres per tree in the island. And this shows the system going in with soil being placed in it. The great thing is, though, that this particular council puts a monetary value on the trees using the Burnley method. And they've been tracking those trees with the stem caliper and the canopy volume, etc., over time. And he actually hit his target of shading in less than 4 years, about 3.5 years. And valued by Burnley, those Platanus there are worth $17,500 each after 4 years. Now, what I love about this is the sort of language that the developers of this world understand. If you go and say to them, well, can you tell me one asset that you could build that will appreciate at all? Far less at this sort of rate. And it's huge, seriously significant. They also had a tree, same species, in the parking yard for their depot, which was planted 15 years ago, just in the old cutout in the asphalt. You know, cut the asphalt through, remove some road base, put some planting mix in there, concrete curb around it, plant tree, etc. That tree was planted 15 years earlier, has a value by the same method of $510, and it's probably really on its way out. So by using proper planting methods and sufficient soil of the right type, they grew trees that were worth 34 times as much in 1/4 of the time. So it's pretty significant, particularly when we're looking for percentage canopy covers, to think how is the quickest way we can achieve this canopy cover. So we've got all the data, we've got the annual statistics of those trees. If anyone wants a copy, let me know. I can give you a report on it. And the shading, even just the shading. So we put a drone up there. So this is the trees here. Those ones there in the lawn were planted at the same time. They were slightly smaller when they were planted. These ones were, I think the numbers are here. They were slightly, I think the stem caliper was similar, but they were a smaller bag when they went in, these ones here. But we are seeing more and more that trees in a properly engineered vault with the right sort of soil will far outstrip trees that are growing just in lawn. It's a very interesting phenomenon. I'll just flick through some of these because I do want to touch on another. This is an interesting one. This is only fairly new, but this is a town in a coal mining region where the council wanted to remove coal dust from the water, but then connect all the tree pits and rain gardens up for proper filtration. So these road pits here have got a filter in them, and via a pipe system, they're feeding that water to the soil in the vault system under the pavement.
So the pit in the road, the soil media under the pit in the road, does that filter the pollutants out and then put cleaner water in under the tree? Is that what the design is?
Yeah, the pollutants get fixed in the soil, the loam soil, And fortunately, this is something that's been well researched, is when polluted water is introduced to a soil profile, at what depth is that fixed? And a lot of the real nasties are actually dealt with in the top couple of 100 millimetres. And yeah, you might say we don't want to introduce pollutants to a tree pit, but there is such a thing as phytoremediation, and it's far better that it be fixed in the soil there than get into the river system. Now, there's a lot of, I won't have time today, but there's a lot of details around engineering and under drains and bypasses and all that sort of stuff which is needed to make this work. It's not expensive stuff, but that's part of this. This is a shot from Walt Disney. We do a fair bit of work with Walt Disney in the United States. That's how their trees come in an 80-inch box on this particular planting scheme. That's that planting, and that was a couple of years afterwards. There are Quercus virginiana. This is Central Geelong. So Geelong are doing some great work with their green spine, or the Revitalizing Central Geelong project. That green cycleway is basically got the tree pit system underneath that for extended soil volume for the trees. And then they're also doing trees out past the cycle lane in what is going to be the parking lane of the road carriageway. So we see that happening a fair bit. Everybody's starting to get the message that to get those big canopies, we also need space for a proper root system underneath. Then where do we find it? That's where this becomes a very much an engineering discussion. Revitalising Central Dandenong. That was one of the earlier projects we were involved in. Those trees are looking very nice. Quercus palustris. And the City of Adelaide have been using this for the last several years now. They did the thermal imaging thing. They got heat maps of the city, identified the hotspots, identified a system that would allow them to shoehorn trees into the laneways and streets of Adelaide, and they've been rolling that out progressively. And there's a number of engineering challenges, as we know, but it's working for them. This is a bikeway they've placed in there. So these ornamental pairs, they've got a tree pit under that concrete there for the spread of their root system. Bank Street Laneway, Hindley, there's quite a few of them there. This is that project that I mentioned earlier in Kansas, where we suggested treating the water before it gets into the pit. But it's utilising space under a big wide sidewalk to get some healthy tree canopies into. Downtown Las Vegas. So the good thing about this is it enables us to grow trees in areas that have previously been regarded as too hostile. And the story that they were telling themselves in Las Vegas was, we can't grow trees here. It just basically doesn't rain. It's too hot. But it's working. They are getting tree canopy there. And then if you go to the other end of the extreme in North America, you've got Edmonton, Alberta, which is one of the more hostile growing zones. And yeah, we've got a project there which is taking road runoff through these storm pits, and that area under there is one, and it goes under the sidewalk, there is one continuous vault for the soil. I want to just touch on this. Have you heard of Bartlett Tree Laboratories? Some of you may have been there. We were involved in a trial there. Very, very nice gentleman that some of you will know, Tom Smiley, put in a comparative trial some years ago called SUP, the Soil Under Pavement Trial, and invited us along there because they were using some of our systems as part of the trial to be involved in it and to be involved in the deconstruction. So we've been there several times. This is at the Arboretum there in Charlotte, North Carolina. And this is a photograph of the trial. So there's, I think, 5 or 6 different tree planting methods that were under trial, and that was repeated, I think, 5 times throughout here. And then the plan was to cut them down, measure and weigh the canopy, remove the roots, the root mass, measure it, weigh it, photograph it, all of that stuff, catalogue it. So the final report's not out yet. But I was fortunate enough to be there working along with some of these other gentlemen, and so it was a beautiful place to work. It's a very, very attractive place to be. The Arboretum there that Bartlett have invested in. It's a very impressive firm. I think it's currently in the second or third generation ownership. So here we are where these are the plots after the canopy's been cut off, and we're using pressure washers and air spades, as well as a big hydrovac truck to expose the root systems, remove the root system, and various different methods were being trialled. So this is a control tree. So this just had soil that was not under compaction and a bridging piece of concrete just sitting on top. So there's a bunch of those control trees there. There were some where they put the soil in and then compacted the soil and put the concrete on top. And then they did some with our system, some with another system. Then they did some gravel-based structural soil and some sand-based structural soil. This is the gravel-based structural soil, which, to be honest, was a fairly disappointing exercise. They used a couple of our systems. This is an earlier one. This is the strata cell system. Those roots grew everywhere, as you can see. In some cases, they had to cut the things out. This is another system here with posts. That's James Urban there. Then this is all the root systems being taken out and washed and weighed. Very interesting exercise. This is Tom setting up for photography. It's all taken very seriously, and the report will be coming out soon, I'm assured. It's just taken a little while to pull together, but the end result was that it verified what we all know, is that uncompacted loam soil grows the best trees. Essentially, that's what happened. Soil that's not under compaction and the right sort of soil grows the biggest trees the fastest, and that's what the results showed on the day. So this is the crew from Bartlett, and really enjoyed working along with them. And this picture here is just one of my favourite ones. This is actually, you've probably heard of the New York City 1 million trees program. I happened to be in New York when they were planting the ceremonial 1 millionth tree. It's at Joyce Kilmer Park in the Bronx, and there was a ceremony the next day with the whole silver shovel thing. So, any questions? Yes?
One of the questions that I've been asked when proposing your structural cell system is, do you need to pull up the entire infrastructure when it's time to remove the trees?
Yeah, that question does come up a bit. No, you do not. Okay. Essentially what you do is, and this does come back to correct design. I mean, talking about the Bartlett trial, I mean, that was bad design. They just sat a tree hard on top of the cells. So those roots are just tangled up with the cells. In our standard recommended designs, a lot of the projects we see now, the tree root ball actually sits in an opening. And then the roots grow into the soil that's within the structure. Now, if that tree fails or reaches the end of its life or whatever, the recommendation is just do exactly what you do with any tree. Just go in there, right, remove the canopy, cut the roots if you can, but grind the stump out, create space to plant another tree, put some more soil in there, and the roots of the new tree will use the decaying roots of the old tree basically as a corridor, that's how it works, yeah. Yes?
Typically, what sort of depth do you do your soil when you do your pits?
It depends. It depends on a number of things. Depends on the level the depth of, if we're bringing water into the pit, it's going to be relative to the depth of the mains stormwater pipes so that we can get positive drainage from the base. But typically it's a metre. Most of them seem to be about a metre. So by the time you have 200, 300 for the pavement thickness, then you have 700 to 800 for the vault system. That takes to about a metre. We have done some deeper. And it's more a function of also the overall volume. So we're better off to go wider, as a friend here was saying with the tree root systems, particularly in Australia, where it's typically shallow topsoils, a root plate is broad and shallow. That's partly why engineering's been such a big part of what we're doing, is because we want to be able to bring that rooting space as close to the surface as we can. The closer you come to the surface, the more intense the applied pressures are from vehicular traffic and so on. So the weaker system you use, the further below the finished pavement level you have to bury it, if that makes sense. Yes?
Was it 2 metres of shade for 1 cube of soil? Was that?
Yeah.
With that, does that include the space loss due to the cell itself, and roughly what is that portion? Oh,
it's not much. It's about 6%.
Okay.
Yeah. So, yeah, and we're basing that off the 3D models of the actual structure, and like adding up the volume of what's in that structure, subtracting that from the overall envelope. Yeah, so the soil, the free volume is about 94%. So, yeah. Yes, up the back.
In your loams, are you inoculating with any microbes?
There's room for a lot of development there. Yes, very interested in that. Our biggest problem at the moment has been to try and, just to start a little bit further back, a lot of these systems end up being installed by civil contractors, not by arboricultural experts. And sometimes if the specifications on the project are not real tight, just anything can go in there. So we have got a recommended outcomes-based soil specification that's put together by a firm called SESL. Simon Leake's firm put that together. It helps, but there is scope certainly for looking into inoculation with microbes. Yeah.
Yeah, with installing measuring services, we've constantly had kickbacks. Well, the people in between saying that they can't install over top of water or gas or electricity. I haven't yet found any examples as yet for installation above services. Have you got that available?
Yeah, we've got a bunch of pictures. If you contact the office, yeah, we've installed above services. We've had services running through them. End of the day, it comes back to the supply authority and how cooperative they're feeling and how well they understand the concept. But there are different ways of, we've had plenty of services running through the matrices. Sometimes we stop and start and create a bridge above. There's lots of different ways of doing it. And we've got a bit of a document and we've got some photographs of different services being integrated into the pit.
Mr. Rogers, bringing introduced soil into a tree pit, does that create just a big pot plant sort of effect? Will the roots actually grow outside that end of the ledge and
we want,
stuff, or do they just
no, it's valid. We want them to. I mean, the situation you're talking about will be exacerbated if we're trying to confine the roots. So if we're overplanting, if we're putting too big a species in too small a pit, yes, that will become an issue. What we're trying to do is allow for the life needs of the tree in that pit. Now, you can't always do that. Now, we would love, this is another issue that comes up a bit, is can we leave the edges of the pit open for root egress so the roots can get out into surrounding subgrade. We don't use root barriers around the edge of the pit unless it is stipulated, unless there's a service has to be protected, roadway to be protected. We like to leave the other sides open so you can get lateral movement of water through the profile, and roots can get out if needed. The only other situation is in the more highly engineered situations where it's in a roadway, for example, we don't get much choice, and often there has to be like an engineered collar around the outside to make sure that the roadway is fully supported. So in some situations, the engineers have the final say. Important thing is to try and provide enough soil for the life needs of the tree. If that helps. Yes?
Do you have much trouble with waterlogging?
Not if they're designed properly. So essentially, when the pit is opened up, you need to see if water sits there. There's not that, if it's a totally free draining soil, we come across this a fair bit in Perth, that the sandy soils underneath, it's not a problem. A lot of other areas we get water sitting there and we have to have an under drain, like a drainage layer, under drain connected to the stormwater, or at least to remove water, because we don't want to create a bathtub. Yes?
Can these be retrofitted for encroachment into tree protection zones, and is there much actual call for that on the development side?
Don't get a lot of call for that. Has been done. We've got a series of images of it being done in Singapore with our system. It needs to. If anybody asks me that question, I say carefully, yes, it can be done, but only under the supervision of a qualified consulting arborist, because it involves exposing roots, may involve cutting some roots, involves protecting roots while the system is assembled around it. But yeah, it can be done, and it does provide a new lease of life for the tree, with it can open up a complete new area of soil for the root system to move into.
Probably one last question if it's out there.
The shelf life, or the length of time before it degrades, how long, how old does it have to get before it's structurally unsound?
Yeah, no, that's valid. We've done some research on that. And look, it's a plastic product, right? But the actual original polymer has got virtually an unlimited shelf life. We have issued a 100-year design life statement on the system. We also, because we're in this green space, we have a company policy of only using 100% recycled plastic. We could use virgin, it would make life a lot easier for us. We only use recycled plastic. Puts a lot of focus on our quality assurance and so on in the manufacturing process. But quite happy to say that in Australia alone, last year we removed close to 1,000 tonnes of plastic from landfill, potentially ocean. So that's our policy. We are sticking with using 100% recycled plastic.
Are you testing, say, the oldest sites you've used?
Sorry, what was that?
Are you testing the oldest?
It's hard to test because they're buried. We have done destructive cyclic tests. We had to do that for the City of Auckland when we did the waterfront over there. It was actually placing at a university lab, placing one of these vault systems under cyclic load 10,000 times and then crushing it to see if the ultimate load strength was compromised, and it wasn't. All right, thank you very much, everybody.